Okay. Okay. So I'll wait for a few minutes for people to join, then we'll start. Okay. So Harshit, is that clear to you, whatever I'm teaching right now? Harshit, is that clear? Am I audible?
Yes.
Okay. And everything is clear now, till now? So what we are doing certain properties of continuous functions. So this is quite important for your examination. Okay. Harshit, is that clear? अभी आवाज आ रहा है मेरा?
हाँ सर.
Okay, good. So now see, another property that I want to explain is sometimes you can say the same thing that if I want to write. So you've seen, let's say I've taken an example and showed you that, let's say I'm taking fx equal to x squared. It is a continuous function. And if I write that my x lies between -2 and 2, I could see that my function attained a value 0 and also attained a value 4. Value 4 was attained at 2 and this value was attained at 0. So your function attained minimum and maximum. And these minimum and maximum values were attained somewhere from this particular domain only. Is that clear?
Yes.
So it means that I'll write it in this fashion, that suppose f is a continuous function. Suppose f is a continuous function defined on a closed and bounded interval. Defined on a closed and a bounded interval a comma b. This is what we were doing. Then there exists some point x0 and y0 belongs to a comma b such that f of x0 will be some minimum of function where x lies between a and b, and f of y0 will be some maximum of function where x lies between a and b, and your function f of x will lie between f of x0 and f of y. So your function will attain maximum and minimum, and these point x0 and y0 will come somewhere from a comma b only. Is that clear? So your function will attain maximum somewhere in the interval a comma b, closed interval a comma b, and it will also attain minimum somewhere in the interval closed interval a comma b. Is that clear or not clear?
Yes, sir. Clear.
Okay, thank you. So that is all that I have to tell you in this in this thing. Then we'll move ahead, and I'll एक और चीज समझने की कोशिश करते हैं. Always remember that the conditions that I have given here, are only sufficient. They are not necessary. What does it mean? I'll make you understand. The conditions here are sufficient, but not necessary. What does it imply? I'll make you explain. Don't worry. So if your function is continuous, and it is defined on a bounded interval, then your function will be bounded. Okay. If your function f is continuous and it is defined on a closed and bounded interval, then the function f is bounded. This is a sufficient condition, not necessary. Okay, that is, it may be possible that your function is bounded, but your function is not continuous. It may so happen that your function is bounded, okay, but what? Your function is not continuous. Is that clear or not clear?
Yes, sir. Clear.
Okay. So let us take an example to understand this. So let us take a function f of x given by, let's say, 1 and 2, and let us take that it is equal to 0 and 1, and whenever x lies between 1 and infinity. So your function is bounded. because after all your function will either be 1 or 2 only. So whatever I can say that my function will always be less than equal to 2 and greater than equal to 1. So either my function is 1 or either it is equal to 2. So it is bounded. But it is discontinuous. It is discontinuous. And also this I, the interval I that I was referring to, it is neither bounded nor closed. So it may so happen that if, say, what I want to say, that if my function f is continuous on a closed and bounded interval, then function is bounded. But if I say that if your function is bounded, does it always imply that your function must be continuous in a closed and bounded interval? Answer is no. Example, I've taken a bounded function, let's say 1 and 2. So your function would either be 1 or 2. So you can write that your function is either 1 or 2. So it always lies between 1 and 2 only. So it is a bounded function, but it is discontinuous. Also, it is not defined on the closed and bounded interval. So it is defined on 0, infinity, which is neither closed nor bounded. So it is unbounded. So if a function is bounded, it is not always necessary that the function will be continuous on a closed and bounded interval. If a function f is continuous on a closed bounded interval, fine, f will be bounded. Are you getting my point or not getting my point?
Yes, sir.
Okay, this is not how you are taught at JE level. That's why I'm teaching you at this level so that you will start exerting your brain. समझ में तो आ रहा है ना, वो चीज बता दो बस. If it is that the case कि नहीं समझ में आ रहा, then it will be a problem. Okay. So what we are doing right now, we are doing some properties of the continuous functions. First property is you have to remember that if your function f is continuous, defined on a closed and bounded interval, then your function f would be bounded. Okay. अच्छा, एक और चीज समझने की कोशिश करो. None of the conditions can be dropped. None of the conditions can be dropped. What do I mean? What was the condition? That f must be continuous. F must be defined on closed and bounded interval. None of the condition can be dropped. Let us say that my function f, let my function f is, f must be continuous. That is, f must be continuous. देखो पहली चीज क्या लिखी हमने, f कंटिन्यूस होना चाहिए और किस पे डिफाइन होना चाहिए बेटा, क्लोज और बाउंडेड इंटरवल पे डिफाइन होना चाहिए. आई एम सेइंग नन ऑफ दीज कंडीशंस कैन बी ड्रॉप्ड. एक चीज तो समझ में आ गई ना कि ये सफिशिएंट है, नेसेसरी नहीं है. बिकॉज अगर f बाउंडेड है, then it does not necessarily imply that your f should be continuous on a closed and bounded interval. If your function f is continuous on a closed and bounded interval, then f is bounded. But if your f is bounded, then it does not necessarily imply that your function f is continuous only on closed and bounded interval. It may so happen that your function is discontinuous on an unbounded and open interval. I'm saying that none of these conditions which I'm mentioning on this side, which I'm underlining, can be relaxed. So for example, f must be continuous. This is very much true. Say for example, if I take example of f of x, let's say it is 1 upon x, where x lies between 0, 1, and at x equal to 0, let us define it as 0. Fine? Or 1, let us say. Now, what can you say about the interval? Is it a closed and bounded interval? Function is defined on which interval? Harshit, can you answer that function is defined on which interval?
Sir, it'll be close, no?
Function is defined on 0, 1. Is it clear?
Yes, sir.
So function is defined on a closed and bounded interval.
Yes, sir.
What is the range of the function? So you can clearly see that your function would lie between 1 to infinity, isn't it?
Yes, sir.
So your function is unbounded. So you will say why? So what I told, not even a single condition can be relaxed. So here you can see that your function is discontinuous at 1. Clearly you see,
Yes.
clearly you can see that your function is discontinuous at 0. Is that clear? Clearly you can see that your function is discontinuous at 0. So here at x equal to 0 plus, your function is going towards infinity, and at exactly x equal to 1, your function is 1. So clearly your function is discontinuous. So this theorem will not apply. This theorem will only apply if your function is continuous on a closed and a bounded interval. So you cannot relax even a single condition. So if I relax the condition, simply I defined a function on a closed and bounded interval, and then I thought whether my function will be a bounded function. So here is an example which suggests that it may so be possible that your function may become unbounded. So here is an example. So your function must be continuous. This particular condition cannot be relaxed. Is that clear? Now condition number 2. Okay, your function f must be defined on closed interval. It must be defined on a closed interval. Let us say your function is defined on open interval 0, 1. So I'm not including 0, and this is open from here. So it is not defined on a closed interval. Now let us take an example of function which is continuous. Let us say your f is continuous. कोई ऐसा example लेते हैं. So let us take a function f of x is equal to 1 upon x. Clearly this function is defined on this interval. 0 include नहीं किया देखो. Okay, and you can see that your function is clearly continuous. Discontinuity कहाँ आती है? 0 पे आती है. 0 तो आपने include किया ही नहीं इसके अंदर. So from 0 to 1, you can clearly see that I can make it using without lifting the pen. So it is clearly continuous, isn't it? Yes or no, Harshit? So your f of x
Yes.
is continuous on open interval 1 and from to closed 1. So it is continuous, but what is range? Range of f is unbounded. So why it happened so? Because why this theorem failed? Because you relaxed one of the condition. Which condition? That f must be defined on the closed and bounded interval. Instead, you just took this off. So from even if you take one side off, that is, even if you remove the close condition of closed interval from one end also, then also your function, then this particular theorem may fail. So you have to remember that whatever I am writing, it is very strict. I cannot relax these conditions. That if my function is continuous on the closed interval a comma b, only then your function f must be bounded. Is that clear?
Yes, sir.
And option number 3, f must be defined on bounded interval only. Must be defined on bounded interval. I cannot generalize this theorem for unbounded interval. So let's say if I am taking example fx equal to x, this is a continuous function for all x belongs to R. So I'll take, let's say x belongs to 0, infinity. It is unbounded, yes or no? Even if I include 0, it is unbounded, yes or no?
Yes, sir.
And what would be range of f? Range of f would also be from infinity to 0. Again, unbounded. So what is the problem? The problem is that I'm not taking bounded. So am I reiterating the theorem? The theorem says that if your function f is continuous, defined on closed interval a comma b, then function would be bounded. Or in other words, function will assume maxima as well as minima, and these maximum and minimum values will be attained somewhere from the domain set. Okay. Okay.
Yes,
Is
sir.
that clear?
Yes, yes.
Okay. So one of the most powerful theorems that you're going to find very useful in your JEE exam also, or I will say at any level of the examination you want to take, like whether you study JEE, okay, whether you take exam of GATE, whether you take exam of JAM in mathematics, whether you take the exam of NET exam in the for PhD entrances, this particular theorem at various levels is going to ask, which I'm going to right now dictate. Okay, this theorem is very famously called as intermediate value property or intermediate value theorem of continuous function. Very, very, very supremely important theorem. Intermediate value theorem. Okay. So in easier words, it is very simple that suppose f is a continuous function. Suppose f is a continuous function defined on closed and bounded interval. Defined on closed and bounded interval a comma b, and let d be a number. Let d be a number between fa and fb. Then there always exists some C belongs to A comma B such that FC is equals to D. So what I want to say that let's say if my function is a continuous function. So my function is a continuous function, okay? And it is defined on a closed interval A to B, okay? And at, let's say at A, my function is f of A, and at B, my function is f of B, okay? And if my function is continuous, then it will take all the values between f and fb. You see, all the values between f and fb are attained. Is that clear? First thing is clear. If my function is continuous, then it will take all the value. It will sweep all the values between f and fb. Is that clear? And if I say that I'll take a point intermediate of f and fb, let us say that point is d. Let us say that point is d. Then this D will be attained for some value C, which lies between A and B. So there will always, you will always find some value C between A and B such that your f of C is equal to D, where D is some intermediate value between F and FB. So for an intermediate value between F and FB, you will always find a corresponding intermediate point between A and B whose image is that intermediate value, that is D. Is that clear or not clear? Should I repeat it all over again? देखो, जो मैं समझाने की कोशिश कर रहा हूं, if f is a continuous function, पहली चीज समझे, क्या चाहिए पहली चीज? f must be a continuous function. किस पे डिफाइंड हो? On the closed and bounded interval a comma b. Okay? हर्षित, am I audible?
Yes, sir.
समझ में आ रहा है ये चीज? नहीं आ रहा है?
नहीं सर, आ ही रहा
नहीं आ रहा? आ रहा है?
आ रहा है सर.
अच्छा. And let d be a number between f and fb. You just take a number d between f and fb. For this d, you will always find a c such that fc is equal to d, and not only that, this c will always lie between a and b. So for any intermediate value between f and fb, you will always find an intermediate value between a and b such that the image of that value will be that this thing. Is that clear?
Yes, sir.
Okay. And not only this, here in the diagram I have shown you only once. It may so be possible, देखो ऐसा भी तो हो सकता है कि a और b के बीच में फंक्शन ऐसे रिपल कर जाए. तो हो सकता है कि let us say if I am talking of an intermediate value, let's say d here. So it may be possible that it may be attained for more than one points. Are you getting my point? So let's say here is your A, here is your B, here value is FB, here value is f of A. So here I'm saying f of A and here I'm saying f of B. So if I'm saying that function attains a value, if I'm saying that D is a value, D is an intermediate value between FA and FB, then if I intersect this particular graph, I can see that this particular D is attained at several points. This particular D value is attained at several points. At several points between A and B. So general theorem I can write that if f is a continuous function defined on closed interval a comma b and d lies between fa and fb, d lies between fa and fb, then fx equal to d has at least one solution in a comma b. मतलब ऐसा कोई जरूरी नहीं है कि एक ही बार काटे, हो सकता है देयर आर मोर देन वन सॉल्यूशंस. देखो यहाँ पे क्या था, तुमने डी पता किया, तुमने कहा कि क्या फंक्शन जो इंटरमीडिएट वैल्यू उठाई तुमने डी, क्या if I'm saying that my d lies between f and fb, then I'm in a query that whether this D corresponds to some value or not. So I'll say yes, it corresponds to a C which lies between A and B. And similarly, here the graph was this way. If I make a graph which is like wiggling infinite times, so at least I can say that at least more than once f will attain value D. Is that clear, Harshit, or is that not clear? Or should I repeat? अच्छा, मैं एक
सर
तरीके से, हाँ जी, is that clear?
एक बार आप रिपीट करना ना सर.
ओके ओके, देखो मेरी बात सुनने की कोशिश करो. थ्योरम बहुत सिंपल है. थ्योरम क्या कह रहा है? इफ अ फंक्शन is defined on closed interval a comma b, so your function will be having a value fb at b and value fa at a. Okay, and if function is continuous, then it will take all the values between f and fb. Is that clear? मैंने ऐसे ही simple graph बना देता. So it will take all the values between fa and fb. ये चीज समझ में आ गई? It will take all the values between f and f. You can see it will take all the values between f and f. Is that clear? Hi, Anashit. Yes or no?
Yes, yes, sir. Got it.
Now, if I take an intermediate value, let's say D, okay, which lies between f and fb, then you can clearly see for this D, I will always find a C such that my fc is equal to D. At C, the value of the function is D, isn't it? And what is D? D is any intermediate value between f and fb. I have written it here, I can write it here, I can find it here, I can find it anywhere. So for each of these value, I can find some point C. Is that clear or not? If
Yes,
I
sir.
take an and this C comes from where? A and B only. So if you say that will my function be equals to D, where D lies between f and fb, I'll say yes, it will be equal to D at some point C, such that fc is equal to D. Is that clear? This is what is clear from the graph also. But here I can only find only one such value. For this particular D, I can only find one such value. Now I am saying it is not necessary na कि continuous function goes in this trajectory. It is very possible that your continuous function wiggles infinite times. Let's say it wiggles infinite times and then ends up at B. Is that clear? Now, if I find any intermediate value, let's say I say, will my function be equals to f of D, and where f of D lies, will my function be equals to D, and where D lies, it lies between A and B. So Harshit will say yes, it will be equals to D at C1. Harshit will say no, it will be equals to D at C2. He will also say no, it will be equals to D at C3. So it may be equals to D for more than 1 point also. Is that clear? So what is the statement? Statement is that if my function f is continuous, defined on closed interval a comma b, and D is an intermediate value between f and fb, then fx equals to D will have more than one solution. Will have at least more than one solution. Will have at least more than one or at least one solution. Is that clear or not clear? देखो ना, fx equal to D. ये fx equal to D को तो solve कर रहे हो. ये जो चीज कर रहे हो, basically कर क्या रहे हो? You're finding all those C whose functional value is equal to D. So fc1 is equal to D, fc2 equal to D, fc3 equal to D, fc4 equal to D, fc5 equal to D, fc6 equal to D. दिख रहे हैं सारे पॉइंट्स पे वैल्यू D तो आ रही है.
हाँ, सर.
तो ये थोड़ा डिफिकल्ट है, लेकिन समझने की कोशिश करो. अच्छा देखो, मेन चीज समझो कहाँ पे यूज आएगा. मोस्टली इन योर थ्योरी ऑफ इक्वेशन यू विल फाइंड द ग्रेटेस्ट ऑफ एप्लीकेशंस. हाउ डू यू फाइंड दैट? सो if f is a continuous function, if f is a continuous function on closed interval a comma b, and it changes sign, then there is at least one root in closed interval a comma. How can you say that? So see, your function f is continuous on closed interval a comma b, and let's say it changes sign. So on the very simple, I'll say, let's say my f of a is positive and my f of a is negative, and let's say f of b is positive. Is that clear? So your function is changing sign. F of a is what? Negative, and f of b is, let's say, positive. So let's say your f of b is positive, f of a is negative. आया ना बेटा, ये चीज समझ में आ गई? Now if your function is continuous, obviously it will go on like this only. It will intersect somewhere between. So your function is from negative to positive, so it will attain zero at some point. यही लिखा था यहाँ पे. If your function is if there is a value d which is lying between fa and fb, then for this particular d you will always find some x such that fx equal to d. At least one x you will always find, provided it is continuous. Provided it is continuous. So here again see, f of a क्या negative, f of b क्या positive. तो पॉजिटिव और नेगेटिव के बीच में जीरो नहीं आता, तो कोई ना कोई पॉइंट पे तो पक्की बात है फंक्शन इंटरसेक्ट करेगा, कोई ना कोई पॉइंट पे फंक्शन पक्की बात जीरो होगा. या अदर वर्ड्स में देखो, फंक्शन पक्की क्योंकि कंटिन्यूअस है तो इट विल ऑब्वियसली कट दिस एक्स एक्सिस. इज दैट क्लियर और नॉट?
यस सर.
ओके चलो, ऐसा जरूरी थोड़ी, ऐसा भी तो हो सकता था कि योर फंक्शन इज जीरो एट इज नेगेटिव एट अ पॉइंट ए एंड पॉजिटिव एट पॉइंट बी, एंड not necessarily like this, it may go like this also. Okay, so there are how many zeros? There are more than one zeros. So what do we say? That if my function is continuous on closed interval a comma b and it changes sign, very simplistically I have told that f of a, let's say it is negative, and f of b, let's say it is positive, then there is at least one root in a comma b. Root means what? There will be at least one root such that f of x naught will be zero. ये चीज समझ में आई बेटा? I know it is difficult, but is that clear to you?
हाँ सर.
Okay, good enough. So now try one question, and then I will leave it to you. You just revise all these things, and then we'll meet tomorrow. Just try to give this question answer to this question. Let us say my function is defined from R to R. You'll come tomorrow, ना? ऐसा तो नहीं छोड़ दोगे?
नहीं सर.
Okay,
आ
okay.
जाओगे.
डरना मत, मतलब it will take time, but you will start to understand all this. Let's say this is my function. Does there exist a root for this? Does there exist a root of this function? So let's say I'll help you out in this. So just do a guesswork. Try to find f of minus 1. What is f of minus 1? It will be minus 2. Is that clear?
Yes sir.
What is f of 1?
Sir, 4.
Very good. So f of minus 1 is 2, f of 1 is 4. It is positive. So your function is changing the sign between minus and 1. So कितनी root की guarantee होगी? At least there exists at least एक root की तो guarantee हो गई, at least one real root in minus 1 power, or at least one real root in R. बात समझ में आई कि नहीं? देखो फंक्शन अपना साइन चेंज कर रहा है नेगेटिव से पॉजिटिव. अगर फंक्शन अपना साइन चेंज कर रहा है फ्रॉम नेगेटिव टू पॉजिटिव, दिस इज अ पॉलिनोमियल फंक्शन कंटीन्यूअस. सो at least at one point it will intersect, at least at one point. अब इससे ज्यादा अगर हिंट दे रखा होता, then I would have told you other things also, but right now till continuous function, at least you can say that at least one real root is guaranteed. And since it is guaranteed in minus 1 comma 1, minus 1 comma 1 किसका सबसेट है? R का तो सबसेट है, at least one real root in R तो तुम कह ही सकते हो. Yes, there exists a root of this particular function. Yes or no? ऐसे नहीं समझ में आता तो ऐसे समझो हल्का फुल्का सा. देखो x टेंस टू इन्फिनिटी फंक्शन कहाँ जाएगा? x टेंस टू इन्फिनिटी फंक्शन इन्फिनिटी जा रहा है. x टेंस टू माइनस इन्फिनिटी फंक्शन कहाँ जा रहा है? माइनस इन्फिनिटी. सो ऑब्वियस सी बात है, फंक्शन विल इंटरसेक्ट समवेयर in between, somewhere in. I don't know exact intersection कहाँ होगा, but at least I'm sure that at least at one point it will intersect. At least for one point it will intersect. At least. it may so happen that function may go like this also. I'm not saying it may not go like this. It may go like this also. But I'm just trying to say that at least one point is guaranteed. So whenever your function, if it is a continuous function and it changes sign, then at least one real root is guaranteed. Again, I'm stressing on the word at least. One or more than one can be possible. Now we will say, how would I know that whether it is a unique root or whether there are more than one roots? For that, you need to wait till differentiability. Then you will be able to understand there are some theorems. Then there you will be able to understand how to arrive at the exact number of roots. Again, not in every context, but in some context where your question is designed in such a way that you can dig down deep and you can find those roots. Is that clear? So here your theory of equation will not work because तुम्हें कितनी quadratic equation ही तो आती है. अब यहाँ तक C power 5 आ गई. Either you should know how to solve this power 5 equation, which is again, it involves good amount of methodologies. Right now, I'm also not aware of that. But it will involve good amount of classical algebra and you should be quite acquainted with each of these theorems. But right now, if you're not, then what you'll do? Just try to put some guess values. So let us say I place f minus 1. So what is f minus 1? It is minus 2. What is f of 1? This is plus 4. So your function is changing sign from negative to positive. So guaranteed है बीच में एक ना एक जगह रूट मिलेगी मिलेगी. Is that clear?
Yes, sir.
In fact, you will find that minus 1 से 0 के बीच में रूट मिल जाएगी. थोड़ा ध्यान से देखो f of 0 कितना आ रहा है 1. So between minus 1 and 0 there is a root. Is that clear or not clear?
Yes, sir. Clear.
Okay, एक और क्वेश्चन का जवाब दो लास्ट एंड देन we'll finish off this lesson. तुम्हें समझ में तो आ रहा है बेटा? ऐसा तो नहीं दिक्कत होगी?
नहीं सर.
गुड. कहीं भी अटको प्लीज पूछ लेना ना, ऐसा शर्माना मत कि पता चला तुमने पूछा ही नहीं और फिर अपन आगे बढ़ते चले.
हाँ सर.
Here you can see sin x is defined on all real r. 1 is a constant function. X cube is also defined on real r. The question says, does there exist x naught belongs to r such that f of x naught is 0? What I'm asking, does there exist some x naught such that f of x naught is 0? Okay, so again, I'll do this guess value work. So just try to find f of 0. What is f of 0? It is 1. Is that clear? And let's say what is f of minus 2? It will be minus 8 minus sine of 2 plus 1. Minus 8 is, so it will be minus of sine of 2 minus 7. Is that clear?
Yes, sir.
And whatever sine of 2 comes, it will always come between minus 1 and 1 only. And if I want to precisely find where the 2 will be, this is 0. This is pi by 2. What is pi by 2? It is around 1.57. What is pi? It is around 3.14. Okay, what is pi? It is around 3.14. So 2 will obviously lie anywhere in second quadrant. What is second quadrant? Second quadrant is where your sign is positive. So sine 2 will be positive number. And there is a negative here. And there is again a negative of 7. So it will be negative. Is that clear? So f of 0 is 1. F of minus 2 is less than 0. So f of 0 is positive and f of minus 2 is negative. So there exists at least one real root. At least one real root between minus 2 comma 0, or I can say at least one real x naught such that f of x naught is equal to एक ना एक तो root मिलेगी for sure. Is that clear or not clear?
Yes, sir.
Okay, so I hope I'm taking a break right now so that we'll continue this tomorrow. But anyway, try to revise this stuff because I know this is very difficult when it comes to execution part. Okay, and this is something that is going to be asked time and again in your exam. So
Yes,
lately you'll see that this theorem I'm going to complicate it with the Rolle's theorem also when I have this differentiability also given to me. Right now I'm only focusing on continuous function. तो अभी के लिए differentiability तुम्हें दिमाग में लानी नहीं. Only continuous function. सिर्फ continuous function दिमाग में चलनी चाहिए. Okay, एक क्वेश्चन का जवाब चलो. X square equal to cos x. Does there exist a x square equal to cos s, do you think there is a solution for it? Okay, so this is, I'm leaving it to you as a homework. Tomorrow we'll do. Okay.
Yes, sir.
Okay.
Thank you.